Hi folks, welcome back. Today we are diving deep into the internals of React. Finally, have you ever wondered what happens when we call this function createRoot? Well, in this video, we are going to explore its implementation. We will break down each part of the process step by step, so we can gain a solid understanding of how a React rendering system is built. So, without further ado, let's get to it. I created here a diagram that we will follow, but first let's go to the React codebase. The createRoot function is part of the React DOM package, and it's defined within the React DOM root. If you follow the import like this, you will end up eventually inside React DOM root.js. And let's see what we have here. Its implementation can be broken down into 5 main steps. The first one would be validation and initialization. So let's change the diagram. We are at this step now. So here, as we can see, it checks if the provided container is a valid DOM. Here there is a warning if we are in dev mode. And then it set up some configuration options, some variable here that are assigned depending on the option passed as arguments. Next, it calls an internal function called createContainer. We will explore its implementation in a moment. And right after, it registers the container as a root in its internal booking system within this function. This part of the process ensures that React listens to all supported events for the root container. And finally, it returns a root type object created using this constructor function, React DOM root. As you can see here, it's a root type we'll explore later. So let's go back to this function, createContainer. Let me put it here. As you can see here, inside the createContainer function, there is another function called to createFiberRoot. Let's check its implementation as well. The createFiberRoot function sets up the fiber architecture that React uses for reconciliation. We can break down its implementation into 4 main steps. The first step that we can see here, it creates an instance of FiberRoot node with the type FiberRoot, as you can see here. But what is exactly a FiberRoot? FiberRoot is a data structure used by React that serves as a container for the entire application. It manages the state and lifecycle of components. It manages update scheduling. It manages the context API and the hydration as well. Actually, I created another project just to separate those types and some key function for ease readability. As you can see, the structure of the type FiberRoot is here, while the important properties are within this base FiberRoot properties. Let's explore a few of them. Current. This property points to the current fiber node representing the root of the component tree. We will see later what is a fiber. Container info. It holds a reference to the DOM node where the React component tree is mounted. Finished work represents the work in progress tree that is ready to be committed. Actually, once updates are processed, this tree is the version that gets displayed on the screen. Pending lane, suspended lane, pinged lane, etc. Those properties help React manage the priority of the updates. And also we have context and pending context that manage the React Context API. So here we create a FiberRoot object called the root. And the second step here involves calling createRoot fiber, which returns a fiber object. Let's check its implementation as well. Well, under the hood, after setting this mode variable, this function invokes createFiber with the host root as the first argument, as you can see here. So what is exactly a fiber or fiber node? A fiber is an object that represents a unit of work in React. Each fiber corresponds to a single React element and holds data about its state, type, and its place within the overall fiber tree. Essentially, fibers form a tree structure that mirrors the React component tree, allowing React to manage updates and state changes efficiently. Let's check the type of fiber and some key properties. For example, tag indicates the kind of component, functional, class, etc. Key is the unique identifier, as we all know. State node holds a reference to the actual instance of the component or DOM node associated with this fiber. Child, sibling, and return represent the hierarchy of the fiber tree, where child points to the first child, sibling to the next sibling, and return to the parent fiber. Memorized state stores the component state as it was in the previous render. Pending props and memorized props hold the new incoming props and the props from the previous render. And there is an important property where the name is not clear. It's called alternate, which is point to the corresponding fiber in the alternate tree. Actually, the alternate tree, also known as the work in progress tree, is a parallel version of the current fiber tree that React uses to process updates. While one tree is active, the alternate tree is built or updated in the background. This way, React improves efficiency of the updates. There is one particular fiber that stands out. It's called the root fiber. Unlike other fibers, it doesn't correspond to any specific component in the tree. Instead, it serves as the root of the entire fiber tree. It's the one created here using this argument host root. Actually, host root is just a number. As you can see here, for sure it has some special meaning, but at the moment I don't have the details of those numbers, but I will investigate more in a follow-up videos. So let's clarify the distinction between all those concepts: FiberRoot, FiberRoot node, fiber, and fiber node. So bear with me. FiberRoot, this is the flow type of the data structure that acts as a container for the entire React application. Let me show you here. FiberRoot is this one, right? It's the type, a data structure that holds the entire React application. It holds some metadata related to the context API, states, and hydration, for example. FiberRoot node is the constructor function that creates an object of type FiberRoot. It has a property called current that points to the root fiber. Fiber, in the other hand, is the flow type of the data structure used to manage update for each component. Every React element corresponds to a fiber, and these fibers are grouped together in a tree structure. And in the same fashion, fiber node is the constructor function that creates an object of type fiber. Now here is where it gets a bit tricky. There is one special fiber that doesn't represent any React component. This fiber serves as the entry point of the tree, and it's called the root fiber. To summarize, root fiber is the top-level fiber of the tree. FiberRoot, in the other hand, is the container of the entire React app. The property current of the FiberRoot points to the top-level fiber called root fiber. I hope it's clear. So let's go back to our diagram. So this one, this one, this one, and this one. We are here, and that's this one. So here we can see once we create our root fiber, it's assigned to the current property of the fiber root, the one coming from here, and then there is a cyclic dependency where this root is assigned as well to the fiber using this property state node. Here there is some logic to handle cache. I'm not interested in, at least at the moment. We set another property with the state, and then we call this initialize update queue. Let's see how it works. Actually, this function creates an update queue. Actually, this function creates an object of type update queue here. It's a data structure used by React to manage multiple updates concurrently, prioritize them, and apply them efficiently. And the created queue is attached to the fiber by setting its property update queue, as we can see here. Yeah, and we return the root object, which is a fiber root. So let's go back to our code here. So after the root fiber is created, React invokes this function mark container as a root. Let's check its implementation. Well, it's straightforward. It takes two parameters, host root. This is the fiber node that represents the root of the tree. And the second parameter is node. It refers to the DOM element where the React application will be rendered. It sets a special property to the DOM node using this key, internal container instance key. Actually, this key is just a string with a random value. As you can see here, it has React containers and this random key, which is created using mat random. And finally, it assigns the host root fiber as the value to this key. And the next step in this process, the main step I would say, is calling listen to all supported events. This function is responsible for setting up React's event system to listen to all supported DOM events. As you may know, React has its own event system that ensures consistent handling of events across different browsers. This system allows React to manage both native DOM events and also custom events in a unified way. And then instead of attaching event listeners to many DOM elements, React attached most of the event listeners to the root container to reduce memory usage and enhance performance. If we check its implementation, actually it loops over this constant or variable all native events and applies some processing to each one. So I think we understood the big idea, the big picture. We can move on. And finally, the createRoot function returns an object of type root type. We can see here the root type. Actually, the structure is simple. It encapsulates two methods and one property. The internal root property holds a reference to the root fiber, allowing React to track and manage updates and rendering for the component tree. And the two methods we are already familiar with, I believe, are render, used to render the React components within the DOM, the root container in the DOM, and unmount, responsible for clearing up and unmounting the React component from the DOM. We can see here the implementation. Actually, the constructor function just takes the FiberRoot and assign it to this property, and using the prototype here, we attach to it a method called render and another one called unmount. And that's it. We have covered all the key parts of the createRoot function, from setting up the root fiber to managing event and returning the root type object. So if we go back to our diagram, we have done this, this, and this. So let's wrap up by checking out a simple console log of the root object to see its structure in the browser console. As you can see here in this code, I changed a little bit the code we had from the previous video. I extracted the selector into a separate constant to be able to log it, and added this console log. So npx serve output. So here we have our DOM element and the FiberRoot. Let's check the DOM element first to see if we have our special key here, React container with a random key, with the root fiber attached to it, as we can see here. And the root element has the internal root property and also two methods, render and unmount. Actually, this render, we will check it in the next video, is this call. And if we check the FiberRoot, we should have a current property, here it is, that points to the first fiber of the tree, which is our special fiber. There is something a bit confusing to me, is how they handle child and sibling. Actually, I was assuming that it will be an array, but it's not the case. I read in a comment that the structure is a singly linked list, I believe, as the data structure, or singly list tree, something like this. But I'm not familiar with this data structure, so I need to investigate it more. And for sure, I will do a video about it. So yeah, that's pretty much it. That's all I had for today. So thanks for watching, and see you in the next one. Bye.